Let's continue our Encor review of topics. These are the topics that we have covered so far. Let's review now this one within network assurance. We're going to talk about 4.3 configure span, remote span, and ER span. We are going to break down this topic into 3 different sessions. In this first session, we are going to talk about the span. We are going to talk about what is a span, why do we need it, design rules, and the features, which are filter VLAN, filter ACL, encapsulation replicate. We are going to see a couple of configuration examples and troubleshooting outputs. Now, first of all, what is a span? A span stands for Switched Port Analyzer. It allows monitoring traffic on a certain source and sending a copy to a destination port. When talking about a span, we are referring to a process that happens within the same switch. That means that the source and the destination both exist within the same switch. Now, what this feature basically does is monitoring something that could be a port, many ports, a VLAN, or many VLANs, and send a copy of the traffic that is being monitoring to a certain destination, which is usually an interface. Now, why will we need this feature? You could take advantage of this copy that you are doing on real-time traffic in order to send this to some server, for instance, and save that traffic on a really large database. So you can gather enough information to create statistics and charts of what is really going through your device. You could also perform security activities. For instance, you could send this copy to a security device, for instance, an IDS. So you could be able to detect malicious traffic on real time and take actions as soon as possible in order to prevent attacks within your network. You could also capture some traffic and send it to a network analyzer like Wireshark, for instance, so you can observe how your protocols are behaving and see what errors are happening on real time within your network in order to troubleshoot a certain incident within your network. Now, what is the basis for this feature? You can either monitor ports or monitor VLANs. If you're going to monitor ports, you can monitor layer 2 access ports, layer 2 trunks, or layer 3 routed ports. And if you're going to monitor VLANs, you can monitor one or many. Whatever type of monitoring you are performing on the source, just remember that the destination can only be an interface. Now, within the design best practices, you must always think ahead of what is the required bandwidth that you will require for your destination port. Let's put an example here. Let's say that you want to monitor just one port that happens to be 1 gigabit per second, and you want to monitor both reception, traffic that is being received, and traffic that is being transmitted. Now, in order to do so, you will need an interface that is able to handle 2 gigabit per second, because you are going to be monitoring the traffic in both directions. So it will be wise to choose, for instance, a port that could handle 5 gigabit per second or 10 gigabit per second. Remember that in the Catalyst 9000s, you can now have the possibility to have ports that can handle 5 gigabit per second. You have to follow some rules in order to configure this feature. A source port cannot belong to different monitor sessions. A destination port cannot belong to different monitor sessions. Mixing ports and VLAN is not allowed for a source, so you either go and monitor ports or you go and monitor VLANs. A port cannot be both a source and destination, and you can choose disable ports for this feature, so for either source or destination. So this feature is going to start as soon as one source port becomes up and the destination port becomes up. Now let's talk about the features. You can choose to monitor transmission traffic, reception traffic, or you can go and monitor both. The default, if you don't specify anything, is both. The next feature is filtering VLANs. So you can specify what VLANs are going to be monitored. The default is that all VLANs are monitored. The exceptions for this feature is that this feature is only available for trunks. The next feature is known as filter ACL. That is also known as flow-based span or F-span. This means that you can specify an ACL to filter specific traffic to be monitored. IPv4 or IPv6 ACLs are permits. Now, the default is that no ACL is used by default. And remember that this feature is only available on certain switches. The exceptions are that filter VLAN and filter ACL cannot be used at the same time. Now remember that this feature is about copying traffic. You are going to monitor a certain source and you are going to copy that traffic into a destination. When you enable encapsulation replicate, you are also going to copy layer 2 control frames for the traffic that is being monitored. For instance, VTP, spanning tree protocol, and so on. And this feature will also make this copy to include the AO2.1q tags that could exist within the source that you are being monitoring. By default, you are not going to copy control frames, and the copy is not going to include AO2.1q tags. Now let's jump into how to configure this feature. The command that you are going to use is monitor session. You are going to have to provide a number for each particular monitor session. That means that many monitor sessions can run simultaneously within a device. There is a maximum amount of simultaneous monitor sessions that can run on a certain device. That is device dependent. Now, when configuring it, you will first have to define your sources. Remember that you must choose whether you're going to go to monitor ports, one or many ports, or one or many VLANs. You cannot mix that. Then you are going to define your filters. Remember that you have two types of filters, VLAN filters or ACL filters. ACL filters are only available on certain switches, and then you must define your destination interface. And when defining your destination interface, you must choose whether you are going to use the encapsulation replicate feature. The most important troubleshooting command that you are going to use is show monitor session and then the number of the session. So let's examine some examples here. We are configuring this session 1 with one interface as source and one interface as destination. Notice that you are going to see the source interface. In this case, by default, it is going to be monitoring both reception and transmission traffic, and it is going to send a copy to this destination. Notice that we are not going to include AO2.1q frames or taggings. Here we are going to just copy the traffic without the tagging. Now let's see this other example. Is practically the same, but we are enable encapsulation replicate. So we have one source interface that is sending both transmission and reception to this destination interface, and we are going to replicate the source. So we are actually sending AO2.1Q tags and layer 2 control frames. Let's see another example. In this case, we are enabling a filter. We are going to only be monitoring VLAN 1 within this monitor interface. So this is the source interface. We are monitoring transmission and reception, and we are sending a copy to this destination interface. We are sending tags, AO2.1Q tags. We are sending layer 2 control frames as well, and we are only doing so for VLAN 1. In this other example, we are doing the same, but we are only monitoring the reception of traffic. So notice here that it is not showing both anymore, because we are only monitoring the reception of traffic on this interface. We are sending a copy to this interface. We are sending tags and control frames, and we are only monitoring VLAN 1. In this other example, we are actually monitoring a VLAN. We are not examining a port, but rather a VLAN. So we are using VLANs as source, only VLAN 1, and we are sending a copy of whatever is traversing VLAN 1 through this destination. We are not going to include tags or control frames. Now this is the same example, but we are enabling encapsulation replicate. So we are monitoring one VLAN, which is VLAN 1. We are sending a copy to this interface, but we are going to include tags, AO2.1Q tags, and control frames. Now this is a summary of what we saw in this chapter. We explained what is span, why do we need it, the design rules, the features that are filter VLAN or filter ACL. Remember that this filter ACL feature is also known as FSPAN, encapsulation replicate for tagged frames, encapsulation replicate for control frames. We saw how to configure it and how to troubleshoot it.